Hi, my name is Jake Audet. I'm going to be taking the test today for chapter 25 through 26, and I'm going to be doing problem 2. So starting with A, we're given a battery, a resistance, an internal resistance, and a resistor of a resistance. We're asked to find the current of the circuit. So I'm going to draw my circuit, and we have an internal resistance, and we have a regular resistance, or a resistor of a resistance, if you want to be specific. And here's our battery. And our electromotive force equals 9 voltage. And our internal resistance is 110 ohms. And our resistor of resistance is 15.3 ohms. So then we're asked to find the current, and current is going to be I equals V over resistance, but we need to find the total resistance first. So we do our total equals 15.3 plus 1.10 equals 16.4 ohms. Then we do the current equals 9 voltage divided by 16.4, and it is in A, okay, equals 9 divided by 16.4. It's going to be 0.5, I'm just going to round it up to 0.55 A. So that is our current. And yeah, it's I equals 0.55 A. I will put that right here to show our current. So the next problem is find the potential difference across the resistor. So for B, we were asked to find what the potential difference across the resistor. Okay. So for this one, we're going to use Ohm's law. Voltage equals current times resistance. Since we have the resistance and we have the current, which is going to be 0.55 times 4. And wait, potential difference across the resistor. And then, okay. So to find it, we're going to do voltage equals the current, which we just found is 0.55. And we're going to times it by the resistance, but not the internal resistance, 15.3 times 15.3, which equals 8.4 voltage. And now for C. Oh, I'm sorry. That's why I was confused. Oh, I'm sorry. This is C. I was like, why? Basically, this is C. I'm going to do B right now. Because I was wondering, I was like, why are we already on the potential difference across the battery terminals? Sorry, B was right under it. Wait. Hold on, I'm confused. I'm sorry. Hold on. No, they're just both the same answer. Okay. Starting now. This is B. Sorry, I was like, I clicked one of the parts and it made it disappear, and I was really confused. And I was like, where did my problem go? Why is it asking me how to find the potential difference? But moving on, this is how you do B. You do the voltage times the current times the resistance, and do the resistance of the circuit, not the internal circuit. Moving on to C, which asks us to find the potential difference across the battery terminals, which the formula for that is the voltage terminal equals the electromotive force minus the current times the internal resistance, which equals 9 minus 0.55a. Sorry, I'll do the times, what was it? The smaller resistance, which is 1.10. Which gives us 8.4 volts. Okay. Again, I'm sorry about that earlier. I got them mixed up when I pressed without my, but yeah, we get 8.4 volts, and that is for the potential difference across the battery terminals. The battery equals 8.4 volts. Okay. Now moving on to D. Just checking. Am I recording? Yeah, we're recording. Okay, when an automotive battery with an EMF of 12.6 is connected to a resistance 24. Resistance of current in the circuit is 0.405. Find the potential difference across the resistor. Okay. For this, we're just gonna use Ohm's law again, because it's just asking again to find the, the potential difference across the vector, which for that we use Ohm's law, which is gonna be, again, voltage equals current times resistance. And in this case, our voltage is what, 12.6 times 24. Oh wait, sorry, this is the current. This it's gonna be, sorry, I'm getting my numbers confused. It's gonna be 0.45 times 24, which is gonna equal, sorry, I was writing it this way, it's making me confused. 10.8 volts for the potential difference across the resistor, which was the current times the voltage. Wow, along with that, I'm also going to make the diagram now, since we have a little bit more information. So here's the circuit. For the next problem, I see we're going to have an internal resistance, but we do not know it yet. So I will fill it in after I solve it. Here's the battery. It's going to be 12.6 voltage, and here's our regular resistance, which is 24 ohms. Okay, so we have, the only thing we're missing is the internal resistance, and we just found out the potential difference is 1.8 volts. So now for E, we are looking for the internal resistance of the battery, which we are going to use the voltage internal formula first, which is the electromotive force minus the voltage. Then we're going to plug that into the internal resistance formula, which is R, or the resistance, equals the electromotive force minus the voltage, which is what we did from earlier, but this time divided by the current. So let's do the first one. 12.6 minus the volts, which we found was 10.8. 10.8 and it's going to be 1.8 over the current, which is 0.45, which gives us 4 ohms for R. So here we're going to put, this is the internal resistance, and now we have everything. the internal resistance, we have the regular resistance, we have the voltage potential, the battery. Okay. Moving on to F, which asks us to find the current in this circuit. And this time I'm gonna make the battery first. Actually, yeah, I'm gonna make the battery first. I mean the circuit first. We are given the battery, we are given voltage, resistance. Okay. Here's our battery, plus minus, electromotive force, which is 1.5 V, or voltage, sorry. Here's our resistance, which is 20 ohms. And other than that, we are not given an internal resistance. And wait, when it's connected to a light bulb with resistance, find the current in its circuit. Okay. So we're just going to use Ohm's law again, which is going to be current equals voltage over resistance, and we are given both, which is, if I'm not mistaken, it's 1.3, yeah, 1.3 over 20. Which is 0.065 A. And this is for the current, yeah. 0.065 A. Still don't have that internal resistance, but oh shit, sorry, excuse me, I dropped my pencil. Moving on though to, what was it, G, which asks us to find the internal resistance of the battery. Internal resistance was it was electromotive minus the volts. Okay, I'm just thinking, give me 1 second. Okay, we just plug it back into the formula. I was just making sure. V internal equals electromotive minus V, and then we have the resistance equals electromotive minus voltage over current, and which is going to be 1.5 minus 1.3, 0.02 or 0.2. It's going to be 0.2 over 0.065. 2 divided by 0.065, which gives, sorry, I wrote a V here. I mean, it looks like a V, but this is an R. This is resistance. 3.07 ohms. And we get our internal resistance. I'm going to round up, actually. It's going to be 3.8. Should have rounded up. I just saw the number. And 3.8. So here's our circuit, battery, our resistance, internal resistance, our current. And then, yeah. Moving on to H, which asks us to find the smallest resistance to which this battery can be connected to for the short times. Okay. And we're given, we draw our thing. Yeah, we have a new diagram. Make this one a bit smaller. Motive force equals 1.5 V. Here's our regular resistance. And our resistance is, we have an internal resistance of 0.16. And I think that is it for now. Okay. So we are asked to find the smallest resistance to which this battery can be connected for short times. And for that, we are going to use the current with resistance formula. Or the current with the internal resistance formula, which is going to be current equals electromotive force over the resistance plus the internal resistance, so that we can find that resistance. Because we are also given the current, I just saw that, equals 2A. So 2A equals 1.5 V over R plus 0.16. Put that into my calculator. Well, first we gotta move stuff over. So we're gonna do R plus 0.16 equals 1.5 over 2, which 1.5 divided by 2 is 0.75 minus 0.16, which gives us 0.59, wait, 0.75, okay, minus 0, okay, 0.59, yeah, I was like, I remember getting 0.59, I forgot the decimal, ohms, and that's our answer. And now we have found the resistance. The external, this is the smallest external resistance. So, smallest external resistance. Oh. Yeah, and then I'm just gonna put that in our thing. Put smallest R, which is gonna be 0.59 ohms. So, or sorry, R min. I just saw the answer. It says R min. So we basically, again, used the internal resistance, or the current with a internal resistance formula, which was current equals electromotive over the resistance plus the internal resistance. Switched a couple things around. We got the smallest resistance, the resistance minimum, sorry. So now we just have I, and for I, we need to find the potential difference across the battery terminals when it is connected. And for this, we use the V terminal formula equals electromotive force minus current times the resistance, or the internal resistance. So where is that? 155 minus 2 times okay, where's that? 1.16. I was like, where is? It's like I just wrote it, which gives us 1.18 volts. And there we go. Volts. Okay, there we go. So I think that's it, yeah. For this one, we just plugged in the V terminal formula to find its potential difference across the battery terminals, and we got 1.18 volts. Thank you so much for watching my test. Here is a closer up video if you want to see. And there you go.